Man, we got a great group here. And from Tokyo, they can hear me. Okay, folks, we're going to go ahead and get started. It's 8 o'clock, and I like to keep this around 30 minutes, but it typically goes to about 30 to 45. Got a pretty full webinar schedule here. I want to show you a couple different things. So first of all, welcome everyone to, I think this is the third OraPub Firefighting Friday. These are my how-to webinars for free. So before we get into it, I want to introduce myself. If you haven't met me or seen me before, my name is Craig Shallahamer, and I'm a longtime Oracle DBA, and I specialize in Oracle database performance, also in predictive analysis, forecasting, that kind of thing. So I do a lot of performance research. I do a lot of experiments, and I post the results of those on my blog. So if you want to know what's on my mind, one of the best ways to find that out is to actually go to my blog. And I try and post once a week, but that doesn't tend to happen. So for sure, once every 2 weeks. I do have a couple books, Oracle Performance Firefighting, which is still selling strong. People are loving that book. And Forecasting Oracle Performance. That book has been around for a number of years, and I think that'll last probably forever. And I do a lot of conference speaking, a lot of teaching, and I mentor a lot of DBAs who want to specialize in database performance. And I'm also an Oracle ACE director, which is pretty cool. So if you ever want to contact me, by far the best way is to simply email me at craig@orapub.com. Okay, feel free to email me anytime. If you do not hear back in 2 days, email me again, please, because sometimes emails don't make it to me, and my emails do not make it to you. So about OraPub. OraPub, the company's been around for about 16 years now, and as you might guess, it's all about Oracle database performance tuning, and we specialize in training in Oracle database tuning. And there's three primary ways we do that right now. We got in-class training. We have the online videos, which are going really strong. I'm on target to produce one of those a month now. So we have 7 total now. So if you haven't checked those out, you ought to check them out. I mean, I think it's a fantastic value for $65 US dollars. And then we have, of course, the Firefighting Friday webinars. So, and there's a lot of tools on my website, and I'm going to talk about a couple of those tools today as we go through what we're going to be talking about. So here's the topic for today. First, I'm going to show you how to install R, which is a free statistics package. And the reason I'm using R is because it's free. I use another package called Mathematica for a lot of my stuff that I do, but R is free, and it's actually really easy to do some basic statistics. So then I'm going to show you how to do a couple of basic statistics, which should just take a minute to do that. And then I want to show you how to create a histogram. And then I'm going to explain what is a histogram if you've kind of forgotten that from your days at school. That'll just take a few minutes. But then what I really want to get into is once we have R installed and you know a little bit about how to use it, I actually want to use it in a way that is appropriate and actually very valuable for Oracle DBAs. And that is understanding Oracle wait event times. And I put an in there because a couple of scripts I'm going to show you. I'm going to show you how to get the wait event times a number of different ways. And I'm just going to show you actually three of these ways in the webinar here. And then using a tool that I wrote in R, what we're going to do is I'm going to show you how to create a proper wait event histogram. And you'll know what I mean by proper and improper, or improper, in a few minutes. So with that, here are the ground rules. I'm going to try and keep it around 30 minutes. Ask me any questions. Go ahead, just type them in the chat window. I have that on my shared screen. You can actually see that. You might not be able to read it, but I can read it. So ask me any questions, but be aware that you are being recorded. And again, feel free to personally email me with any questions. So as I said, this is being recorded, and I will try and get it online within 3 hours. Usually I can do that. So you can actually, forward your friends that, hey, who missed the webinar, hey, this is recorded and online. And all the tools I'm going to use, you can download these things for free. I want to make sure I do that for the how-to webinars. And as a side note, hey, please, if you have a scenario that you would like me to take a look at that may be appropriate for a webinar, let me know. Okay, and then I will email you about that, and maybe we can use that. Okay, so now we're in the meat here. Here's the situation. A colleague of mine, he's just freaking out. Why? Because he says the average sequential reads is 4 milliseconds. That's fine. But then he sees a bunch of read times that are over 1 second. So he thinks something is broken, essentially. Okay, he got the data from $V event histogram, and which is the main core view that we're going to look at today. And he's really ticked off, okay? And he's upset with the IO subsystem team, and he wants to go just start yelling at these guys. So what we need to do is to figure out whether or not it's appropriate him and it makes sense for him to go to the IO team. And if it is appropriate, what's he going to say? So that's the situation. And in some of my consulting work, I mean, I literally have recently run into this over the last month. So this does happen. So our objective is we want to understand the true weight situation, right, by analyzing thousands of weight occurrence samples, not just a few, but we want to get thousands. And then, of course, we want to help people understand what's happening. So what I'm going to do, the tools I'm going to use today are all in my OSM toolkit, right? You can download that thing. I just put a new release up actually yesterday. I'm always changing this thing. And these are the 3 scripts that I'm going to use. They all start with SW for session weight. The script names are a little cryptic. I don't know how else to call these things. And what we're going to do also when I start really typing today, I'm going to put an artificial load on a little test machine that I have, and I'm going to use a toolkit called OP Load. OP is for OraPub, and it's just free. You can download that. It's a real simple load generator that I use for a lot of my experiments. And also, I'm actually going to use real AWR data. We're going to pull direct from AWR data to create these histograms as well. So the key time is really between 10:30 and 11 in the morning. And the data I'm going to use actually comes from August 1st. So it's getting close to, well, about 9 months ago. Okay, so that blank slide means it's time for me to start typing. So it looks like everybody's actually here. So that's a good thing. Okay, so first thing I'm going to do is I've actually logged onto my test server right here. And I hope you all can see this. And good, I still have my connection. And what I'm going to do, I'm going to go to my load generator. Okay, and this is what, if you downloaded this off my website, you would see this. I'm going to put a physical IO load on the box. Okay. And so that's what the PIO means. I'm going to make this a little bigger so you can see this one right here. So there's my load, and I have a number of different loads I can place on the box. I was thinking I should have used locking today instead of physical IO, but I didn't want to test that out this morning early. So that starts the load on the box, and it's just going right now. So we're just going to kind of let that keep going. Okay, so what I want to do now is I've connected. I'm going to log into Oracle System Manager, and I want to take a look at the key view that we're going to look at, which is $V event histogram. Okay. Oh, that is a little big, isn't it? Let's see if I want to get this as large as I can so you guys can see this. Because on my screen, it's huge, but it's not always like that on your screen. Okay, that's good enough. So we're looking at this key view $V event histogram, okay? And you can see that it's event specific, and there's this is not self-explanatory right here. And I'll tell you what that means in a second. And these are the weight counts. Every time there's a weight, right, this column is going to get updated for every single weight event, but it's kind of confusing what it actually, what it actually is going to show. So what I'm going to do, I'm going to issue a select statement here, and I think I already have this typed in here to help me out. And then this is going to make a lot more sense once I do this. Okay, so what we're looking at, is these wait time, this is for milliseconds, these are called bin sizes. This is kind of like a histogram. So for the wait event, DB file sequential read, right? And this is since the instance has started. Every time there's a DB file sequential read, that wait occurrence is going to increment one of these wait count buckets right here, or bins. So if the wait time is less than 1 millisecond, this bin is going to be incremented. Okay? If the wait time is greater than 1 millisecond, but less than or equal to 2 milliseconds, this bin is going to get increased. Okay? So it's like a histogram, except there's one big problem with that. And I want to ask you a question here. Okay? These are called the bin sizes, or the buckets right here. Is the size or is the duration of the bins, are they uniform? In other words, are they the same? Are the bin sizes the same? Think about that while I run a script here real quick. So are these bin sizes here, are they uniform? The answer is no. Okay? The bin size for this one is 0 to 1 millisecond, bin size is 1. The next bucket, 1 to 2 millisecond, bin size again is 1. The next bucket, it goes from 2 to 4, the bin size is 2. Now 4 to 8, that bin size is 4. 8 to 16, that bin size is 8. So the bin sizes are growing in powers of 2. So they are not uniform. The problem with that is that if we try and visualize this as a histogram, which most people naturally will automatically try and do, because the bin sizes are not uniform, it's like an improper histogram. We are trained to look at histograms with bin sizes that are actually the same. Okay. Now, if you're in some, if you're doing some science and you're used to looking at bin sizes that are not uniform, you're going to be used to this. But most of us, people like you and me, we are used to seeing uniform bin sizes. And so this can be a problem. So that's why we have an R script to help us take these inappropriate, let me just, if I can use that loosely, bin sizes and turn it into a proper histogram. All right. So what this is showing me, this script I ran right here, this is pulling straight from $V event histogram, just when the wait event is DB file sequential read. And it's just like this script that I did up here. Okay. In fact, I can show you the sequel on this thing. You can see it's pulling from $V event histogram. Okay. But the difference here, I just like it's formatted, it gives me a percent and a running total right here. The reason the numbers can get greater than 100 is because there's just the way the script is written. Sometimes it actually happens. So don't worry about it. Okay, so what this is saying here is that almost 100% of the DB file sequential reads are between 0 and 1 millisecond since the instance has started. Okay. Now, while for sure there were 234 DB file sequential reads that were between 32 and 64 milliseconds. So you could say, well, that's quite a few. But in relationship to all of the events, it's like nothing. It's just static. It's like what, 0.01%. So even if you happen to see some large wait times, it's important to put it into perspective. Okay. All right. So, but this is since the instance has started. So typically what I want to do though, is I want to know what's happened within the last few minutes, something like that. Okay. So I'm going to run another script here, which I just have an X on the end, which gives me a clue that I have to run it twice. And I'll show you what I mean in a second here. Copy this. So basically this is taken like an initial snapshot of what's going on. Okay. So now, in fact, don't even look at, this is not what we care about right now. This script took an initial snapshot of the wait times for DB file sequential read. Okay. It took an initial snapshot of that. now I'm going to run the script again. And this is what's happened since I ran it last time, which is about 27 seconds. So hopefully that makes sense. If I run it again, it's been what, maybe about 15 seconds? 13 seconds. This is what's happened in the last 13 seconds. So just in the last 13 seconds, there were 3 DB file sequential reads that were between 8 and 16 milliseconds. Okay? So this is a nice little script to interactively to see what's going on your system. Okay? All right. So I wanted to show you that so we understand what $event histogram shows us, what these bin sizes are all about, and how that relates to the counts. Okay, so we've got that. Now it's time for, I'm going to shift, and I'm going to show you how to install R. Okay, I'm getting some comments. Sometimes some of you cannot hear me. Yeah, I'm sorry about that. I think this is the best that it's actually going to be. Some of it is my voice, I think. Could be internet connection too. All right. Well, somebody said they got good audio. Thank you. Yeah. Sorry if the audio is not good. I've heard that before, and I don't know if it's my internet connection or what. But okay, we're going to shift now, and I'm going to show you how to install R. R is really, really simple to install. Oh, in fact, I'm going to stop the load generator. Okay, it stopped. Okay, let's install R. Here's what you have to do. This is, I'm serious, this is the simplest install I've ever seen. So I can't really see this. Well, you know what I can do? I think zoom, there we go. You go to rproject.org. That's the R statistical package website. Okay, and if you forget, you can actually, figure this out. I mean, you just do a search on Google. It's pretty obvious. It says download R. There you go. It's always right in the front, even if the page looks different. Okay. You click that. It's going to bring you to, It's going to bring you to one of these pages where you can see there's a lot of different download sites all over the world. It's amazing. So I'm going to scroll down to the U.S. And I live in the state of Oregon in the U.S. And there's a university, about an hour away, and that's its FTP site right there. So I'm going to go there. And now you can see you can download for Linux, for Mac, or for Windows. Okay. So I'm running a Mac, so I'm going to go to this page right here. This is actually a little more confusing than it typically is from what I remember. But that's my file right there. I click that, and I'm going to download it. Now, it's about a 70 meg file, and I didn't want to do that during the webinar since that's going to mess up my internet connection. So yesterday, I downloaded that. And that's what this file on the right side of my desktop is. That's this package. Okay, so I don't know if you can see that very well, but that's what it is. So I'm going to double click that, and we're going to install R. Okay, here we go. And this is very similar than it is on Windows. Okay, it's just classic install stuff. I'm going to try and zoom in here. Maybe you can see that better. All right, continue. I'm just going to take all the defaults. Of course, I agree to the things I never read. Install it. Here it goes. It wants my password. Just about done. Definitely less than a minute. Got it. I'm done. R is now officially installed. Can't get any easier than that. Okay. Now, how do I start R? Well, you got to find the program. If Windows, you probably have an icon on your desktop. I just do a search for it. So on my Mac, I type R, and that's the logo. I don't know if you can see the logo right here. That's the R logo. So I know I'm looking at the right program. I'm just going to start it. Boom. There's the main console. Okay. Now I think you can see that. Okay. Yesterday, I actually worked on, making it a little easier to see. Yeah, there we go. Gotta love that, man. All right. So there's R. All right. So that's the console. So let's let's ultimately create a histogram here. So what I'm going to do, I'm going to go to my website, believe it or not, because on my last blog posting, I showed you how to do this. Hey, do you guys like that picture? I think that's so funny. My wife didn't like that. She thought that looked really stupid, but I think it looks pretty good. All right. This is one way to get some data. We need some data. So before we start actually using real histogram or real $V event histogram data, I'm just going to create some sample data. All right. So I'm going to take that. I'm going to paste it right in here. And now I have 20 samples between the numbers 1 and 40, and they can be replaced. In other words, I can have multiple of the same number. All right, so let's take a look at my data. I just type whatever I call it. Boom, there's my data. By the way, I could have called this SS for sample set. My data is not what's important here. Okay. And you'll see this is a different numbers here. Okay. Now what I want to do is I want to create a histogram. Here we go. My data. Type it in. Boom. There you go. Now, if you've ever tried to create a histogram in Microsoft Excel, it's a stinking nightmare. This, talk about a breath of fresh air. You actually type hist my data. Yeah, it's super simple to do. You can resize the window. You can do all that kind of stuff that you want to do. And if you want to make it look different, you can change the axes, the titles, you can change the color. And I showed you how to do some of that in my blog. Okay, this is the same kind of thing we just did. And it's very easy to make it look much more appealing. So creating a histogram is super, super easy in R. So I wanted to make sure you could do that. Now we're going to go back to Oracle, and we're actually going to then use R to create some histograms from $V event data. So let me get one of my, here, that's what I'm looking for right there. Okay, I got to relog into Oracle because my session was killed when I stopped the load generator. Oh, I actually want to keep the load generator going. Dang. Okay, we got to start it up again. Okay, so the load generator is going again. Hopefully there's not going to be a problem there. All right. Oh, what I'm going to do now is I'm going to show you a couple of the scripts that we have. Oh, here's my OSM toolkit right here. This is the latest version. It's on the right side of my screen here, my icon. I'm going to double click that. Okay, and boom, it created a directory called OSM, and this is it right here. Okay, so this is it on my desktop. There's my directory, and what we're going to look at as some scripts in this interactive directory. And I'm going to go down till I get to the SW scripts for my session wait. These are the scripts that we're going to look at today. Just those three. I'm going to open those up. My screens. There we go. I'm going to open those up with my text editor. I use Text Wrangler for this. And here are the scripts. So the first one I want to use is I'm going to be gathering data directly from the live system. Okay. Now the beauty of this script, okay, and this is the name of the script here. This is it right here. The beauty of this script is that there's no DML, there's no DDL, and I do not use DBMS lock sleep. The reason I created this script is because if you're a DBA on a system where you don't have a lot of access, it's a production box and you can't create objects there. You can't use sleep. Basically you need to be able to copy and paste statements, right, that don't create any objects. You're just basically selecting. So that's what this script is really good for. I figured out a way to do this without any DDL. Okay. And so what I'm going to do is I'm going to pull directly from $V event histogram based on the load that's being generated on the box right now. And there's a couple different ways I can do this. I can copy and paste the code here, right in SQL+, or I can just have SQL+ prompt me for values. So that's what I'm actually going to do right now. Okay. Here we go. And because I use defines in this, there's 3 parameters, which you can put on the command line, or if you just run the script interactively, it's going to prompt you for these. So this is what's going to happen. The script is going to cycle. It's going to loop up to a maximum of the number that I want to put in here. And I'm going to put in 40,000. Okay. But I also am going to put in a maximum or like a minimum number of samples that I want to collect. And I'm going to put 8,000. You say, that's a lot. Well, it's going to happen really fast on my system here. So what's going to happen is that this script will be gathering data. Okay, gathering data, or it's going to be checking, looking at $V event histogram, and it's going to check either 40,000 times or until it notices there have been 8,000 weights related to the weight event that I care about, which is DB file sequential read. Okay, so let me say that again because it's kind of confusing. I don't think I said that very well. Essentially, this thing is going to gather data until either it cycles 40,000 times or it notices that there are 8,000 samples related to DB file sequential read. Okay, so whatever of those hit first, then it's going to exit the loop. Okay, and here we go. It's going to start running. Now, that was pretty quick, right? And it's not too exciting on this system. Okay, notice the bin sizes here, just like the Oracle bin sizes, right, from $V event histogram. And so it hit. Let's see, did it actually hit? Yeah. Let's see. Oh, okay. I got 8,000 samples. So I asked for a minimum of 8,000. So I got those. So I didn't actually hit the 40,000 loops. Okay. Of the samples here, almost all of them, the DB file sequential read time was between 0 and 1 millisecond. Okay. Pretty boring, not real exciting. Okay. Let's try it again here. Okay. Let's go for a different weight event. Actually, I don't know if I want to do that because I haven't checked. Let's go 50,000 maximum loops, and instead of 8,000, let's go 15,000. Whoops, that would have taken a while. And we'll stick with DB file sequential reads. Success load on the box. Okay, here we go. And this will take a little bit longer. Now, if you noticed up above here, I'll say, man, what kind of output is that, Craig? I mean, that is really cryptic. The reason it's like this is because we're going to take this output and paste it directly into a script that's written in R. And that's what this little tool is right here. This tool right here, I'm going to copy and paste what this report gives me. I'm going to copy and paste it right below the examples that I give you. Then we're going to take the entire script, we're going to copy it and paste the entire script directly into R, and boom, it's going to create a bunch of histograms for us. I mean, it can't get any easier than this, right? All right, let's see. We probably should have gotten this back. Here we go. Not too exciting, right? So I have over 15,000 samples, event histogram, there were over 15,000 DB file sequential read weights where the wait time was between 0 and 1 millisecond. There was only one single occurrence of DB file sequential read that was between 1 and 2 milliseconds. And you can see here that I'll just take the 8 to 16 millisecond. There was only one occurrence of DB file sequential reads. So I can literally take this right here. I copied that. I'm going to go to this script right here. Okay, and that is not the current name. All right. And I'm going to paste it right here at the bottom. It's the only tool in my toolkit that ends with .r because it's an R script. So I'm going to paste this in here. Okay, this came from right here. So there's no tricks. All right, I'm going to select the entire file. I just did a copy. In fact, just so you can see here. All right, I did a copy. Now I'm going to go to R. So I'm in R right now. Okay. In fact, if you ever get concerned about your data, like the stuff you've been doing beforehand, you can always just exit R, don't save it, and start it up. And it starts fast. I do this all the time to make sure like my work environment is clean. Now I'm going to paste. So I'm going to edit, I guess plain text. It's going to go boom right in there. And it takes a second or two, boom. So I have a couple of histograms and I have some nice stats right here. So let's look at the stats first, and then we'll look at the histograms, which are actually pretty boring. So of all the samples that I gathered, right, when I was just interactively gathering the information, the maximum value was like 5.8, right? And here are the quartiles right here. So the average was 0.5, which is half a millisecond. So on average, all my DB file sequential reads that I collected were took on average a half a millisecond. But there was at least one occurrence that was 5.84. So on average, it's super quick, but sometimes it's a lot longer, which is very typical in Oracle systems. Okay. Now let me show you the histograms here real quick. And I should be able to, there we go, make those a lot bigger for you here. Okay. Now I got a number of these histograms. It's really boring right now, so I'm going to show you some real examples here in just a second. But this is a smooth histogram right here. Okay, and you can see that if this, you can eyeball this, and you can say, well, if that's 5 milliseconds, then this is 1 millisecond, and like all of our samples are essentially in 1 millisecond, which is what we actually saw, right? And this is the histogram that we'll typically focus on, because I only go up to 50 milliseconds here. Right? That's the maximum milliseconds that will cut off here. But because our maximum wait time was like 15.8, it only goes up to 15.8. So when this line ends right here, that's like our largest sample will be on this, like at the end right here. All right, now that's pretty boring. That's not real exciting. So let's actually look at some real data. And then we're going to pull from AWR. Okay, so this is the data that I actually collected, right? Right there. That I collected in SQL+, this stuff right here. Really boring. So I'm going to get rid of that. And I'm going to use one of the examples from actually real production systems. I have a number of examples right here. Okay. Okay. Now this is important right here. This is an example from log file sync. These values came from an actual AWR report, not from the DBA hist table that I pulled from. These came from an AWR report. And if you notice the times, see the 16.7, 11.2, these are not the actual count values in the bins. These are the percentages. And that's what the AWR report shows us, right? When we look at the event histogram area. So what I did, I went to an AWR report just for the wait event log file sync. I actually typed in the percentages related to each bin. Okay. And this R script, it can handle that, and it'll create the histograms for you. Okay. In fact, I didn't plan on doing this one, but I'll use it. So let's say this is what we wanted to do. I had my AWR report. Somebody handed it to me. I have questions about, the average wait time may be fantastic, but I want to see what's going on when bad things happen. Okay. So I'm going to put this data at the bottom of my examples right here. Boom. So it's the last one. I'm going to select it all. I just copied it, and now I'm going to paste it into R. Okay. Here we go. I pasted it, press return. Now it's going to create the histograms. Boom. All right. So here's an example. Okay. The maximum value was about 256. And if you actually look here, you can see where that came from. 0.3% of our samples were between 128 and 256 milliseconds. Okay, so that's where that comes from. Here's the average. The average wait time, and this was what, log file sync? Yeah, so the average log file sync was 14.3 milliseconds. That's pretty slow for log file sync. People, that's probably why this example is actually here. Usually people want log file syncs, well below 5 milliseconds. So let me explain this quartile stuff here, okay? All right, so there's our maximum value, the third quartile. This means that 75% of all of our samples are less than 20 milliseconds. Another way to interpret this is to say that 25% of our samples are greater than 19.5 milliseconds. All right, so somebody says, well, how bad is it? Well, you can say, well, 25% of the log file syncs were greater than about 20 milliseconds. They might not be too happy about that, okay? I can also say that if I use the median, that's the 50th percentile, I can say that 50% of the log file syncs are less than around 11 milliseconds. I can also say that 50% of the log file syncs are greater than 11 milliseconds. And that to me is like half of the log file syncs are greater than 11 milliseconds. That doesn't sound real good to me, okay? I can only say that 25% of my log file syncs are less than 1.7, okay? All right, so there's a real example of where you could actually take the data, what I did here, directly from an AWR report. I would actually just type these in, right? The other way to get data here, I can pull it right from SQL Plus using this script right here. Okay, so that's another way. Okay. Finally, what I want to do is I want to show you how to actually pull the data directly from an AWR report. Okay, so this is going to be pretty cool. This is a great situation if somebody says, hey, like an hour ago or yesterday or last week or last month, we had some I/O issues, let's say, or we think we had I/O issues. Can you give us more than just the average wait time? Okay, so that's what I'm going to do right now. Okay, now I'm going to stop the load on my box here just because that's just going to slow some things down. Whoops. Okay, if you hear some background noise, honestly, there's some guys doing some work on where I live. They're building a fence and they're sawing right now outside my window. And I've tried everything I could to muffle the sound, so I hope that's not too irritating for you. Okay, so this is the last thing we're going to do. We're going to pull data from AWR. And this script, I'm going to use this little script right here. This session wait, event histogram, AWR get. Really simple to do this thing. You just type it in, and it's actually a very simple script. The objective of this script is to create output that I can paste directly into that R script, just like I have been doing. So essentially what I've done is I have one like master R script that creates a bunch of histograms. And I have a number of scripts and a number of ways for you to get output that will create the output that you can simply paste into this R script. And what I'm showing you now is just another way to get that information, and that's going to be from an AWR report. So I actually am connected to Oracle where I have AWR data available to me. So here we go, WR get. Okay, now I have to pick, of course, the data, the DBID, the database, and the instance number, and I need to, pick my snapshot interval, just like when I run an AWR report, right? So I'm going to say I want to get, that's my DBID, and I'm going to go on instance 3. This is a rack system here. And now I want to kind of give the general time that I want to start and stop. Okay, so for this example, and I told you this was, remember, August 1st, it's 2014, and really it's between 10:30 and 11, I think, was the problem time. So I'm going to put between 10 o'clock in the morning, and I'll put 12 noon right here. Okay. And now these are all the different snapshots, AWR snapshots. And what I want is between 10:30 and 11. That's the key time where I've been told that I need to take a look at, because that's creating some problems. And remember, the DBA is freaking out because he's really concerned about the times that he's seeing. So I need to put in the beginning snap and the ending snap. So the beginning snap is the 32053. That's 10:30 time. And then the ending snap happens to be the next one, because these are 30-minute snaps. Okay. So this happens really fast. I got to give the wait event. We're going to go for DB file sequential reads. DB file. Yeah, I think that's, I don't know if I better put DB file in there. Okay. Boom, got it. Pretty cool, huh? Right out of the AWR tables right there. Okay. Hey, by the way, you might be wondering, why do I talk about DB file sequential read so much? Okay. The reason I do that is DB file sequential read is a very clean, a very pure IO. It's a single block IO that a foreground process, a server process, makes to the operating system. And the way it's instrumented is the server process essentially asks the OS, what time is it? It records the time. It makes the IO call for one block, and it waits. And that's the DB file sequential read wait time. It waits until it gets the block. When it gets the block, it asks again, what time is it? So it knows that for one block, it knows the ending time and the beginning time. So it knows how long it took. So it's a synchronous read. So it's a very good way from an Oracle perspective to find out how is the IO subsystem performing from a read perspective. So that's why I look at DB file sequential reads a lot, because it gives me clues about the IO subsystem without actually running IO subsystem commands or having to figure out where the Oracle database files physically are on this massive IO subsystem. So that's why I look at DB file sequential reads. All right, so here's the output from our script. So again, I'm just going to take the output right here. I'm going to paste that into my R script, which is right here. That's not my R script. There's my R script. In fact, I want to get rid of these two histograms. All right, so I'm going to paste the values right into R. Boom, there they are. Oh, whoops. No. I did that wrong, didn't I? I take these values, I put them in the R script. I paste them in there. So now that's the last example. I select the entire R script. And by the way, if you want to, this is the R code that does all the things that need to be done to create the histograms. So I'm going to copy the entire script. I'm going to go into R, okay, and I'm going to paste. And I should get my histograms here. There we go. Now, these are a lot more interesting. So let me spend a couple minutes and talk about these. Now, first of all, there's our statistics. Okay. So the average wait time, what you would see in your typical wait event report, you would see the average wait time for DB file sequential read over this snapshot interval of 10:30 in the morning to 11 in the morning was about 2.5 milliseconds. That sounds pretty darn good, right? That's less than my rule of thumb of 10 milliseconds, clearly. However, though, we hit a maximum value of 232 milliseconds. That's like a quarter of a second to get one stinking Oracle block. That is forever, okay? That's the bad news. The good news is, right, 75% of all the DB file sequential reads were returned within like 3.4 milliseconds. That's fantastic. So it's these few infrequent large values. So how do we visually show this? That's what the histograms are going to do for us. Okay. So you can see the line here goes out to the maximum value, which was 232. That's 232. And we can see that most of the weight events are not right down here, which we'd expect. So this is the chart. This is the main one I typically look at for sequential reads right here, okay? We know, right, that this only goes up to 50 milliseconds. So we know that there are occurrences over here. But as we can see, right, there's not very many, very, very few. Okay, and if we actually look at the underlying data that I pasted right here, we can see that, yeah, there are a few occurrences here, okay, but they're not very many when they get big. All right, and we can see this visually in a proper histogram where the bin sizes are actually uniform. Okay, and this is actually really typical of IO and Oracle. You notice it kind of generally we kind of shoot up, and then we get a really long tail like that, right? So in other words, we have a bunch of samples that are between 0 and 1 millisecond, but we have more samples that are between 1 and 2 milliseconds, and then we don't get as many samples right here. So you get this quick buildup, and then you get a really long tail. I mean, it's extremely, extremely long tail right here. So the typical value, not the average, the typical value is going to be the median, which in this case is really close to the average, the mean. So the typical value is going to be right in this big hump right here, in the mode, how we would officially call that. So that's the typical value what people are experiencing. Okay, so let's bring this to a close now. Bring it to a close. Okay, what are we going to, okay, should the DBA go to the IO subsystem guy and go berserk because he's seeing some big wait times right here? The answer is no, because typically and usually we have super fast wait times right here for the sequential reads. Yes, sometimes they're really slow, right? But it's not very frequent. So in this case, one of the solutions is not to go to the IO subsystem guys and say, we need more IO read capacity. Okay, so that's kind of the bottom line on this particular data set right here. Okay, so that's it. So that's it for the webinar. I hope you guys enjoyed that. We got to see a lot actually. How to install R. Oh, I didn't show you how to do some basic statistics. Oh yeah, we did. If you type summary, that gives you this information right here. That's kind of the basic statistics. And I show you how to do that on my blog as well. So that's how you install R. Do some basic statistics, how to create a histogram. Remember, we create a histogram with simply the hist command. I can actually do this. And where'd that go? I don't know. It's around. Anyways, shows you how to do a real basic histogram. How do we get wait time values from VW event histogram? Through a number of ways. Through interactively looking at your system, from a physical AWR report where we type the percentage values in, or we can pull directly from the AWR table as well. And we were able to create proper histograms, and to help us do that, we used R. So we went through a lot of stuff. So that's it for today. I'm going to be around for questions. And by the way, if you have a scenario where you would actually like me to look at and then potentially use, let me know about that. The recording will be online in a few hours. I will post the next webinar in a few days. And if you have topics that you would like me to cover, let me know about that as well. And if you have any questions or comments, you can always email me, or you can just chat right now. So this brings us to the official end. If you have any questions, I will be on here for as long as you guys want to ask questions. All right. So thank you for attending today's OraPub Firefighting Friday how-to webinar. Have a fantastic weekend, and thanks for joining us. So those of you that want to stay, go ahead and ask questions. I will look at the chats here very closely and answer any questions. Haresh, thank you. Appreciate the comment. Chang, I appreciate that very much. Okay, Mike from the Midwest, who's not going to give us the actual state, says we don't have AWR. Is there anything that can be used with StatsPack? I believe so. StatsPack also collects the $V event histogram information. So if you run a StatsPack report, you should see for the weight events, you should see the event histogram details, and you could enter that in just like an AWR report. You could also just modify my AWR script to actually pull the values straight from the StatsPack tables as well. In fact, it's probably called, right, stats $event histogram, something like that. Okay, I haven't checked. And if you want to, email me that, and I can always create a script for that as well. That would be a good idea. All right, Rajesh, thank you. Thanks for joining us. From Tokyo, thank you. Oh, Jeffrey, he said, why don't I just, and this is from Seattle, he says, why don't I just basically suck the data right into R using a SQL? You could do that. R can actually pull, and I can actually create the connection string in R to pull from another data source, whether it's a text file, whether it's Oracle or another database as well. The reason I did that is I want to make it super easy for people to do this. And anytime you got to have a connection string, and anytime there's a user and a password and stuff like that, it just adds complexity. So this is like a no-brainer, and I can use this when I do my consulting work, on any platform, and I know it's going to work for me. I don't have to worry about the connection information. So that's why. But for sure, you can do it. And if I was like a typical production DBA, I would probably actually want to do that because I know the exact situation in my environment. So that's why. All right. The Tendra. Hopefully I said that right. Thanks. Appreciate you attending. Have a great weekend also. Any other questions?